All right, let's get started. Today we're going to be talking about inheritance, and that's going to build up on classes, which we talked about last class. So first, here are some lesson objectives. Today is going to be relatively short and easy. In terms of like content, we will only be talking about inheritance, but it will be building on the stuff that we talked about before. We will first talk about introduce it. Relationship between subclass and superclass. And if you don't know those words, vocabulary, don't worry, because we're going to teach them in class. Modifiers and the roles they play. And then if we have time, or if you need to, I can demo a little bit before we get to the problems. And then of course, not all the problems will be like done on by yourself. I can also go over some of the problems with you. So let's get started. First thing, inheritance is when one Java class inherits the code in another Java class. Now, on side note, a class can only inherit from one class, but you might be confused as to what inherit means. Inherit in this sense is kind of like having a method, because now you don't have to repeat the code for like every single class that has similar. So for example, we have a class called vehicle, and this vehicle has attributes like it has 4 wheels, it has windows, it has an engine, it can be driven. And under vehicles, we can have cars. And then under cars can inherit from vehicles. So every single object of the car class can have every attribute that the vehicle has, such as 4 wheels, windows, engine, it can be driven. And then, for example, we can also have buses, right? Buses are also a type of vehicle, and buses also inherit from the vehicle class. So buses also has the attributes of windows, 4 wheels, an engine, etc., etc. So this way, you see, we don't have to write our attributes twice. We only have to write it one time and make 2 classes that inherit the attributes from the vehicle class. So like I said here, it's very useful for if you're using code. You can have many classes that inherit from one superclass. And now a superclass, or the parent class, is the class that has the original code. So in the example I just showed you, that would be the vehicle class. The subclass, or the child class, is the class that inherits the code. So in the example I just talked about, that would be the car class, the bus class. So you can think of it as super, as in Superman, and Superman's high. So that would be the higher ranking class. A subclass, sub means below, right? Submarine, right? So sub is the class that's below, that's a lower. And because it's the class that's lower on hierarchy, that's the one that inherits, right? We also call it parent classes or child classes sometimes, but that's more informal. You might meet somebody who says it like that, but in this class, we'll be referring to it as superclass or subclass. Of course, you can feel free to refer to it as parent class or child class if that helps you get used to the idea. Very similar, like parent class is the class that has the original code, and child class is the class that inherits the code. You can also think of code as like genetics. The parent has the genetic, and then the children inherits the parent's genetic. But each child gets does their own thing with it. Like the child is not completely the same as the parent. The child also has some differences from the parent class. That's what we'll be doing with inheritance. We'll be inheriting the code from the parent class and then adding some stuff to the child class, so we don't have to rewrite the code for every single child class. And of course, you can also have shared qualities between classes. So for example, the car class and the car class and the bus class, since they both inherit from the vehicle class, they both have the same attributes such as windows, wheels, and engine. And because you know that they inherit from the same parent class, you know they have the same attributes, which can be useful when you want to write certain code that uses these objects. It's kind of like automatically knowing that if this if this class inherits from the parent class, these two classes will have like a certain amount of attributes that are exactly the same. Kind of saves you some time and energy, so you don't have to go back to the class to look for what attributes they are, something that inheritance just automatically tells you. So here is just a example and a graphic. So you can see here we have class A. Class A has one attribute. This attribute is named integer I. Class A also has one method. This method is named method1, and it's void. It doesn't return anything. Void doesn't return anything, right? Remember? So void just means that it does something. In this case, that's something that it does is it prints out something. This prints out the line from method1. Now, class B extends A. Now, the fact that there is the word extend and then means that this class is a subclass. The superclass doesn't have anything. The superclass doesn't have the word extend. That's how you know it's the superclass. And the subclass has the word extend. So class B, that's what we've done before. Public class B like extends. That's how you know it inherits something. And where does it inherit from? It inherits from class A. Now, you just type the name of the class here to know which class it inherits from. Pretty easy, right? And remember, it extends with the S. If you don't include the S, Java will throw an error at you. I off the top of my head, I can't recall which type of error it will throw at you, but it will definitely throw an error at you when you try to when you incorrectly inherit. So make sure you have the S. Okay, it extends. And of course, you have to spell the name of the class you're inheriting from correctly. Make sure you also spell that correctly. And no semicolon. We only have brackets. Remember, you have opening brackets and closing brackets. Don't forget the closing brackets. If you forget the closing brackets, it will also throw an error at you. Enough about the formation. Let's continue dissecting what's in class B. So class B, it has integer j and it has method 2. Now let's take a look at the graphic over here. Method class A has I, method 1. That's something we just talked about. No questions on that. Class B, J, method 2. Now, normally if class B didn't have the extend A, let's say I cross this out, pretend that isn't there, this would be class B and that would be class A. They would have no correlation between them because they have no, because there's no like inheritance, no hierarchy between them. However, if class B extends class A, now here class is lower. Class is all lowercase. Here class, the C in class is uppercase. I think this isn't like an error. Not, how do I say this? This is just signifying the name. I don't think the uppercase signifies anything. And remember, you should always have class as lowercase when Java, because Java is case sensitive. If you do not have a lowercase c in class, it will throw an error at you. So don't mind this uppercase C in class here, here, and here. Don't ignore that. Don't worry about that. What's important is that class B extends class A means that this class B, this version of class B has I, J, method 1, and method 2, contrary to this class B, which just has method 2 and J. So if we create an object of class B, we can call method 1 and method 2. Now, relationship between subclass and superclass. There are quite a few rules that are associated with subclasses and superclasses. If you don't remember, subclass is the child class, the superclass is the parent class. And let's get started. Number 1, a subclass can access all the superclasses, methods, and attributes. Now, I say all, but when we get to modifiers a little bit later on, you will realize that all have, with the exception of private. I do not see private used that often. It's mostly protected and public, but remember that unless it is private, a subclass can access all of the superclasses, methods, and attributes. Okay. Second, superclass can't access of any subclasses, methods, attributes. Now, it doesn't matter if the subclasses attributes are public, protected, the default private a superclass can never access any of a subclass's method attributes. Okay, that's just a rule. Doesn't matter what the modifiers are, doesn't matter what the subclass is, doesn't matter what the superclass is. A superclass can never access any attributes of the subclass. Now, normally a subclass would have more attributes and more methods than the superclass, so it really wouldn't make sense for the superclass to try to access something of the subclass. But I'm just putting that out there just in case you have that question. A subclass can change the superclass's methods and attributes as well. That is something called polymorphism, which we will not be getting to in this class. We will be getting to that next class, because polymorphism is a very complicated topic with a lot of complicated rules. We won't be getting to that this class. Of course, if you're curious, I can definitely do some demonstrations for you. But as of right now, let's put it on the back seat. All right. Also, number 4, a subclass becomes a subclass through the word extends. That is the only time a subclass will become a subclass. Okay, that is the only way through a subclass a class can turn to a subclass, or a class can turn to a superclass. This class automatically turns into superclass once another class extends it. So, for example, like the example at the beginning of class, which I've done, public class vehicle, public class car extends vehicle. So car is now the subclass, vehicle is now the superclass. Number 5, a class can be a subclass as well as a superclass of another class. That's a lot of classes in that sentence. If you guys look at the graphic, you can see there is 3 types of inheritance here: single inheritance, multi-level inheritance, hierarchical inheritance. You do not have to know the name of these. You just have to know that these are the things that you can do with inheritance. Now, there are also more types of inheritance, but we will not be getting those inheritance, such as, what is it called again? Let me take a look at my notes. Those types of inheritance, such as multiple inheritance or hybrid inheritance. That's what I was thinking. Hybrid inheritance. They are not always supported on by Java. I think it depends on your IDE and also depends on what version of Java you're using. But because multiple inheritance, hybrid inheritance, they're really, how do I say that? They're really complicated. We will not be going over. They are also not as common as single, multi-level or hierarchical inheritance that we have here. So let's take a minute to break down single inheritance. Relatively easy, right? Class B extends Class A. So Class B is the subclass, Class A is the superclass. Class B extends, inherits all of Class A's attributes and methods. Nothing really special about that. We've been going over that all like 10-15 minutes of class so far. Multi-level inheritance. Now, that is what number 5 is actually about. A class can also be a subclass as well as a superclass of another class. So Class B is a subclass of Class A, but at the same time, simultaneously, it is the superclass of Class C. So what happens here is Class B inherits everything from Class A. Class C inherits everything from Class B. And that and by itself makes Class C inherit everything from Class B and Class A. Does that make sense? You can think of it as like, let me try drawing a diagram to see, because this can be a little bit confusing. So for example, we have Class A, Class B, Class C. Can you guys see this? Okay, so here we have Class A. Class A is the smallest circle. Class B inherits Class A, so it contains everything that Class A has. Class C inherits Class B, so it contains everything that Class B has, which also happens to be what everything Class A has. Does that make sense? That is multi-level inheritance. And we can keep going. You can have class B, class E, class F, class G, all the way to Z. Usually it doesn't go that far, because if it goes that far, it's hard to keep track of everything, all the attributes and methods you've inherited. But that's just a possibility. You can do that, but just because you can doesn't mean it's very common. Any questions on single or multi-level inheritance so far? No? Okay, cool. So next we have a hierarchical inheritance. Now, this is just like a hierarchy, and in that both class B, class C, and class D all inherits from class A. This is very similar to the vehicle example I gave at the beginning of class, where I talked about cars and buses. What is another vehicle? When I'm thinking, other than cars and buses, that also has 4 wheels and an engine. Let's do trains. So for example, does trains count as a vehicle? I'm kind of out of, oh, trucks. Okay, that's okay, trucks. So we have, let's say we have 3 different types of vehicles here: cars, trucks, and buses. They are all vehicles in that they all have windows, they all have wheels, and they all have an engine. That's so they all inherit from the vehicle class. That is hierarchical inheritance. Different classes, multiple classes inheriting from one class. That is possible. That is hierarchical inheritance. Now, can class B also be a superclass right here? Of course it can. So for example, class A, let me see if I can make a diagram right now. Let's do like a hierarchy. Let's make a hierarchy. Instead of that, let's make it on a blank slide. Oops. Let's make it on a blank slide. Okay, here we have a vehicle. That's the class vehicle. And then here we have class car. Here we have class bus. See if I can add another. So I can't have 3 levels at the beginning. That's okay. Well, let's just do class car and class bus. So car, we have gas cars, class gas cars. And then here we can also have class electric cars. For buses, we can have class public bus. And here we can have class school bus. So you see how these are, there are like several layers to hierarchical inheritance. The car is a vehicle, bus is a vehicle, gas car and electric car are types of cars, and public bus and school bus are both cars. At the same time, public bus, school bus, electric car, gas cars, they're all vehicles. So they inherit from vehicle, and then they inherit from car or bus. And then if we want to go like further in, like we can also have let's not actually do it because that's kind of like a lot of work, but we can also have like for under gas cars, we can also have like brands of cars, like different brands of cars. And electric cars, that's not supposed to be a space there. For electric cars, we can also have like different brands of electric cars. And for public bus, we can have you know, you guys know like public buses have different routes, right? Like there's the 245, 241, etc., etc. For school buses, different counties for like school, like there's the school bus. This school bus belongs to works in this county. This school bus works in this county, etc., etc. It can go on and on and on. So that's hierarchical inheritance. Now we are mostly like 90% of the structures of inheritance, the other 10% we won't be touching on. So any questions about the structure of inheritance? No questions? Okay. Let's keep moving. Right. These rules are not that important, which is why I put them on a separate slide, but you still have to know them. If a superclass has a constructor, a subclass must also have a constructor. If a superclass doesn't have a constructor, subclass, you don't really need a constructor in a subclass, although it would be nice to have a constructor. If a superclass doesn't have a constructor, Java will automatically make like a default constructor. So you don't really have to do anything. Not that much else about constructors. Number 7, static methods, attributes in superclass will also be static in subclasses. Now, static is a kind of a weird thing. We'll be talking a little bit about it in the demo that I'll be showing you next. And that static methods relate to the superclass, relate to the class instead of the object. So static methods are, you can leave it as static methods are part of the blueprint, contrary to difference, like the difference, like different attributes you see on the actual object that you make. A little bit on modifiers, two slides. They might seem intimidating, like all these different modifiers and what they actually do, but when it gets down to it, they're not that complicated, and we won't be using them much. I will probably be quizzing you on it like once or twice in a problem or something, but most of the time we'll still be using public, so don't feel intimidated. All right, so what are modifiers? We've talked about them like a little bit before, but modifiers are basically words that set the access level of a class. So who can access it, how they can access it, that's what modifiers determine. Now, access, there are 2 types of modifiers. Access modifiers, and these are modifiers that control the access level, and non-access modifiers. Now, I know non-access modifiers sound a little bit crazy, sound a little bit silly, because modifiers, by definition, set the access level of a class. How do non-access modifiers exist? Well, they do not set the access level, but they do have other functionality or uses when it comes to transparency and who gets to see what. So sometimes you don't want people looking at your code, and that's where modifiers comes in. So let's talk about access modifiers first, because they're a little bit easier to understand. There are 2 types of access modifiers: the modifiers for classes and the modifiers for, what did I say? Classes. It's supposed to be attributes. Sorry, typo. So modifiers for classes, we will only be using public and default. Public, it means the class is accessible by any other class, and default means that a class is only accessible by classes in the same package. Now, what do they mean by the same package? Well, let me demonstrate in my IDE. Now, you can see here we have all these different classes, right? All these different classes, and they are of the same package because they are in the same folder right here. They're in this folder called Java class. If a class is in another package, it would be different. They would not show up they would basically, it would not like show up here. If they're in another package, they would basically not show up there. I would probably have another tab open or something. For a Replit, so for example, Replit, create a new Replit, Steam demo. This is a class, add file, car.java, public class, car. This is another class. So Replit, this would mean that they're in the same package. What they mean by not being the same package for online IDE like this? Oops. My Replits. This lesson 7 and lesson 6 would be different packages. Does that make sense? That's actually a really rough idea of a package. And if you go into like higher level Java computer programming and you tell people that's basically what a package is, they'll laugh at you and tell you that's not true. Packages in themselves is very complicated, and we won't be going too much into that. So just know that as of right now, let's take this as what packages are, and let's just take this on as premise and let's work through it before we go into actual depths of what packages are. Modifiers for attributes, methods, and constructors, very similar: public, private, default, and protected. So public, the code is accessible from all classes. Private, the code is only accessible within the class that it is in right now. So for example, if I have public class car and I in the class car I have a private method called max speed, and since the method is private, if I have a electric car that inherits from the public class car, it won't be able to access the method max speed because max speed is a private method, even though the class car is public. Because the method is private, you cannot access it. Okay. However, you can still access the method within the class. So for example, if you want to let's do increase max speed. There's a method that's called increase max speed, and basically increase the max speed, and it calls the max speed, the method of max speed. You can do that even though it's private, it's accessible within the same class. As long as it's in the class car, you can do it. Default, only accessible in the same package. And protected, accessible in the same package and subclasses. So you can actually import or so-called import packages, but we won't be getting into that. That is way too complicated. Let's just stay with default, and we'll probably not be using default that much. I think public and private are the ones that we're going to be using the most in this class and in the future. Default and protected aren't that common. Now for non-access modifiers, I know we usually have a break around this time, but let's just deal with this. After we finish this, we can have like a quick break. All right, non-access modifiers. Again, they also divide into two separate categories. For classes, there are final and abstract. So final, if a class is final, it means that the class cannot be inherited by any other classes. Of course, this class can extend another class, but it can't be inherited. Abstract. Abstract class is a type of class that cannot be used to create objects. Why we have abstract classes is a bit of a long story, but as of right now, we can just think of them as a broken blueprint. Because it's a broken blueprint, you can't use this blueprint to make objects. you can access abstract classes by inheriting. So for example, we can make an abstract class, a superclass. We can make a subclass that inherits the abstract class, and then access the the methods, the attributes, and the abstract class through the subclass. We can do that, but the abstract class in it of itself cannot be used to make an object. We only have like 2 more lessons left, so I don't know if we'll actually be getting into abstract classes, but if there's a chance, I will be talking about them because they are a very interesting phenomenon in the Java programming world. For attributes, methods, and constructors, we have final, static, and abstract. Final, it means that the method can be overridden or modified. That again relates to polymorphism, which we'll be talking about more about next class. Static means that the attribute and method belong in the class rather than to an object. So for example, we can have let's think about this. Okay, we can have a method, a class car, and this class car can have attributes. For example, we can have an int max speed, int min speed, minimum speed, and we can have a static method, number of wheels. And this static method, number of wheels, is 4. So let's say we create a object, object of a class car that's called my car, and we create another object of a class car that's called your car. We can change the max speed and the min speed for your car, and it won't affect my car. We can, vice versa, we can change the max speed and the min speed for my car, and it won't affect your car. However, if we change the number of wheels, it changes the number of wheels for both your car and my car, because static methods belong to the class. So you can think of static methods as like modifications on the blueprint instead of the object. And when the blueprint is modified, the entire object changes. All of the object that inherits from that, all of the objects that are made from that blueprint changes. Okay, not just new objects, all of the objects change. So abstract, no, that's basically static. I don't know if we'll have time to get to it. I might do a demo with static. Abstract only used on methods in an abstract class, has no code in it. Code is provided by subclass. Yada yada yada. Basically the same as abstract for a class. Not really much to say about abstract. And let's me start my demos on how to inherit. Now, before we talk about inheritance, let me get static cleared out of the way, because I realized that the way I was teaching might have confused some people earlier. So I will show how to do how static actually works with a example. So now let's have a new Java class, and now let's name this class car again. Class car, and now in the class car we have public say string name, and we have public private int number of wheels, num wheels. Now let's have a static variable attribute right now. Public static int num of cars. Now, this number of cars, we keep track of how many objects of the number of cars there are. So for example, we can have public car. This will be like the initial constructor, and we can do like, what is it called? Parameters. Let's do parameters. String name, the name of the car, and string name 1. Let's do that. And also string, not string, int num wheels 1, and that would just mean name equals name 1, num wheels equals num wheels 1. There we go. And on top of that, num of cars increases every single time. In that case, let's make a new object of car. So, for example, oops. What do we want to name this car? Do we just still go with like my car, your car? We can do that. Car, my car, car, and let's do see, this is a Ford, and it has like 4 wheels. Car, your car equals new car. This will be one Jeep. We can do Jeep. And also 4 wheels. Now, we can try to print. Out my car dot name. System dot print line. Your car dot name. And if we run this, it'll be Ford and Jeep because that's different. That's different cars, right? However, if we do car, what is it called again? Car dot number of cars. That'd be 2. So Ford, Jeep. I can comment this out actually. That would be 2. If we comment this out, oops, click on the wrong one. I meant to click on run. It's okay, it's still running. 1. It would just be 1 now. Now if we have car, his car goes new car. What's a good brand? Prius. Okay. Let's say Prius has 3 wheels. Doesn't really matter. Number of cars also change. So do you get what static means right now? So static is something that's related to class instead of a single object. Because if it's related to a single object, then it might be different for every single object. But if it's related to the class, it's the same. It's not like I don't want to say it's the same because it sometimes these static variables depends on how many objects there are, but it basically is not affected by like what objects do with each other. Like what you do with the objects doesn't really affect like the class, so it won't affect like a static method. Does that make sense? Does my spiel about static make sense? If it does, I will be continuing with inheritance. Take a look at the chat. No, nothing. Okay, right. So let's continue with inheritance. It's just let me just comment right now. Let me just comment all this out. And let me just delete all this. We'll be inheriting stuff from our class anyway. So vehicle. Did I spell vehicle correctly? Okay, I did. All right, so that is the superclass vehicle. And how do we make it a superclass? So remember, car. Okay, we do extend vehicle. 2 spaces there. Now, what attributes do all vehicles have in common? Let's do public boolean has engine is equal to true. What else? What else does a vehicle have? Let's do like a vehicle can honk. Okay, so public void honk equal hang honk system.out.println. What sound does a horn make? I'm gonna just say honk, honk. There we go. Now, this means if car inherits vehicle, that also means it would have the method honk honk. And now let's make a car, my car equals new car. Oh, we have to make a constructor for a car. What should we make the constructor out to be? You know what? Let's just do Java makes the default constructor. I'm not gonna bother making a new constructor. New car, and if we do my car dot honk, can you expect what that does? Honk honk. Now if we do system.out.print my car dot has engine. Oh wait, I forgot a semicolon. Ah, I already clicked run. Yeah, I know, I forgot a semicolon. True, so it's a car, it's a vehicle, it has engine, so it's true. Of course, a car can has its own stuff as well. For example, public name, the name of the car, we can public string name. String name equals or brand. Let's do Jeep, because we also did Jeep. And let's have a method called public brand name, public void brand name. This will be system.out.println Jeep this car. And when that does this name, this car is a Jeep, so this car is a Jeep. We can also make like a public, what is it, void get name. Let's not make get name, but like what is name? We can do a parameter string name one, name equals name one, and a plus, and we can do that. So over here we can do what is the name of the what is name? Okay, the method is, I forgot the name of the method already. My car dot what is name. Now we do this. Means it should still print out the same thing, right? But if we change it to forward, so you see, inheritance doesn't really change the fact that you can still do these things to objects. It just gives it more like attributes that, you know, this class can have, and another class can also have these attributes. So it doesn't really change what you can't do, what you can't originally do with a class. You can still do with a class. I think that's like, that should be like probably all I should demo for this. Do you guys have any questions? If you have any questions, like tell me, and then I can keep demoing. If you don't have any questions, we have like 9 minutes left in class. We can do some problems, and I can go over some problems. If nothing pops in the chat, or like if no one speaks up within the next like 20 seconds, I will assume that there will be no questions. Okay, 20 seconds. And 20 seconds is quite long, but you know, it takes time for you to formulate your thoughts, right? Okay, 20 seconds passed, nothing came up. I'm assuming you don't have any questions. If that's the case, let us go do some questions. These are pretty simple questions I found online. We can pick and choose. So for example, I will give you, it is now 4:53. So I will give you 30 seconds to do this. I think this is quite easy. If you need more time, tell me in the chat. After you come up with the answer, we can put it in the chat or just say it out loud. Regardless if you get it right or wrong, or you don't know, I'm still gonna go over the questions. Okay, 10 more seconds. If you have anything, put it in the chat. If you don't, that's okay. I will go over the answers. Okay, 10 seconds is up. The answer is actually you cannot, what is it called? Extend two classes at once. So what you can do is you can make class Y extend class X, and then class Z extend class Y. We can't extend two classes at once. Okay, doesn't really work like that. You can't. It's just there's no Y. Java just doesn't allow you to do that. Just something you have to remember. Number 2. Let's not do that. Sure, let's do number 3. What do you think is the output of this program? This is actually a really complicated question. You know what? Let's just go over this question because this is a really complicated question, touch on some stuff that we haven't talked about yet. The answer is 1, 2, 3, and the reason that is because we initialized it as C. But you have to realize C inherits from A. So what it actually does is it goes to A first. It doesn't go like, oh, class C equals new C. Oh, okay, so I will go back to class C, and then class C extends class B. I would do what class B tells me to do as well, and then and then class B extends class A. It goes back to class A. No, it goes from class A to class C. There's reasons behind that, but I actually don't know how to explain it. The reason behind that is quite complicated, but you can just remember that whenever something is inherited, it goes from top to bottom instead of bottom to top. It goes from like the highest level to the lowest level instead of working from the lowest level up. That's why it's 1, 2, 3. That's why this answer, number 2, is 10, actually. So we can go over number 2 as well, because it's basically the same problem, just wrapped in a different skin. We have class A where int I equals 10, class B where I equals 20. Now, you can think that class B overrides class A, but when we have A equals new B, you can do that because it inherits. So B is a type of A, right? So you can do that. When it prints out A dot I, it's actually 10. Well, this is because you initialized it as A. If you initialized it as B, we wouldn't have that problem. 3.5 more minutes left. Let me see if I can demo this. Let me see. Let me take a look at the question. See if I can demo this real quick. So we have the vehicle, which is public and windows equals 2 cars, public windows equals 4. if we have a, just comment all of this out. Oops. If we have a car, if we have a vehicle, my car equals to car, and we do my dot out my car dot windows. This will print out 2 because we started as a vehicle. We initialize this as a vehicle. However, if we have a if we change this to car, it will be 4. You can think of it as when you initialize this as a car, it goes into the car. If you initialize as a vehicle, it goes in from vehicle and works from vehicle way its way down. Not this one. So why did we initialize this as a C, but it still goes from A to C? That is actually because there are no modifiers, and not modifier, there are no constructors, and when you initialize a new C, it automatically calls everything that came before. There's actually no, these aren't actually even in any method, they're just in the class. That's very rare. You see that. Now that I think about it, this might not have been the best problem. So if you don't understand why number 3 works, don't worry about it. As long as you understand why number 2 works, that's okay. Class is officially over. Cool. Bye.